Hello, today we are going to talk about solving equations. There are basically 3 steps involved when solving equations. The first step is to simplify all of your terms in the equations. The second step is to combine any like terms you may have. The third is to isolate the variable by using what we call an inverse operation. And an inverse operation just means the opposite. So if you're adding, the inverse will be to subtract. If you're multiplying, the inverse will be to divide. So that's what we mean when we say using the inverse operations. So let's just go ahead and get started with a few examples. First example, example number 1, what we have here is something called a one-step equation. It's called a one-step equation simply because there's one operation that is present. That operation is division. What we see here is the variable n being divided by 6 to get the quotient of 1 2/10. Well, according to the steps, the first thing we would do is simplify the terms, which they already are. Second is to combine our like terms, and we see that we have none. And then the third is to isolate the variable by using the inverse operations. So the inverse of division would be multiplication. So instead of dividing the n by 6, we are going to multiply this side of the variable by 6. I'm sorry, this side of the equation by 6. And whatever you do to one side of an equation, you must do the exact same operation to the other side of the equation. One thing I like to tell my students is think about the equal sign like a balancing beam. It's balancing the right side and the left side of the equation, meaning that they're both equal to each other. And since both sides are equal to each other, we must do the same to both sides. So the inverse of dividing by 6 is multiplying by 6, so that cancels out, leaving me with the variable n, which is what you wanted all along. You wanted to isolate your variable. Just going to copy the equal sign, and then 1 2/10 times 6. If we do the math, you're going to get 7 2/10. So n must be 7 2/10. Let's move on to example number 2. Now, number 2 is a little different. Number 2 is no longer a one-step equation. This is called a two-step equation. It's called a two-step because you have two operations. We have multiplication. This 1/2 is being multiplied by the variable n. And to that, we are adding a 4. So we have two different operations, hence the name a two-step equation. Now these are a little different. You still have the basic 3 steps, but when you are doing the inverse operation, you want to do your order of operation backwards. So what we're used to doing is please excuse my dear Aunt Sally, which is good when we're trying to evaluate an expression or simplify an expression. But when we're trying to work backwards and figure out what's missing, that also means you're going to do your order of operations backwards. So what you're going to do is add or subtract first, depending on what is in the equation. And what we see in the equation is addition. Remember, your steps is to do the inverse operation. So instead of adding a 4, we are going to subtract a 4 from both sides. 4 minus 4 cancels out, and what we're left with is 1/2 times n equals 6. Okay? So after the first step, which is either addition or subtraction, depending on what's in the equation, you will then move to the second step. You're going to multiply or divide, again, depending on what's in the equation. And what we have here is a fraction, 1/2, being multiplied by n. So the inverse of multiplying n by 1/2 is to divide 1/2 on both sides of the equation. That cancels out, leaving me with n, which is what we wanted. So what we're left with is 6 divided by 1/2. So now we're going back to a previous unit of dividing fractions, which we've discussed in detail. If you don't remember that unit, feel free to go back and look at the video under the Unit 4 playlist. But I'm going to copy, change, and flip. So what I have is n equals 12 over 1, which reduces to 12. So the value of n, in order to make the previous statement true, n must be 12. Finally, example number 3. Number 3 is probably as tricky as it's going to get. This is what we call a multi-step equation. You must do all 3 steps before you even attempt to solve. So what that means is when you look at this equation, first we're trying to look if we need to simplify any terms. So I have a, which is simplified, positive 8a, which is simplified, take away 3a, that's simplified. Come to the other side, we have 2, which is simplified, but over here, 80 divided by 2. That is a term. Remember, terms are separated by addition or subtraction. So that's one term, but it's not simplified. We need to simplify this part of the equation as step 1 tells us to do, simplifying our terms. So 80 divided by 2 is 40. Then I'm just going to copy the rest of the equation. Come over here. So we have simplified the terms. Step 2 is to now combine my like terms. So you're combining all the like terms that are on the left-hand side, and then you'll combine all the like terms that are on the right-hand side. What we do not do is crisscross when we're combining. You do not jump over the equal sign. The equal sign separates. Okay? So if we look on the left-hand side, we have 1a plus 8a, which is 9a, minus 3a to give me 6a. That was easy enough. On the right-hand side, we have 2 plus 4. We can combine those. Those are like terms. That's 42. So now, after we have simplified our term, after we have combined our like terms, what we now have is something very similar to example number 1, a one-step equation. And if you look at this one-step equation, it says 6 times a equals 42. Obviously, the operation that's being done is multiplication. The inverse of multiplication is division. So we're going to divide both sides by 6. That cancels out, leaving me with a to be equal to 7.